Okay, let's start with our first derivation, which is one of the important derivation of this chapter, which is expression for electric field intensity on the axial line of dipole. This axial line dipole is also known as end-on position. End-on position means sometime this question can arise on find out the expression for field intensity on end-on position of the dipole. Right? For this, let us consider a dipole AB having charges minus q and plus q separated by distance 2a. Let P is the point at which unit positive test charge is kept, and this is the point at which net electric field intensity is to be calculated. Let R is the distance from the center of dipole of the point P. Right? Now just remind, or we can say just taken into account the steps to be followed. First step was keep the unit positive test charge at point where we need to be calculated the electric field intensity. So we have kept it here. Second step is find out the value of E1 and E2 due to charges minus q and plus q. Let's continue with the second step. Let E1 vector, this mode indicates we are finding the magnitude. E1 is the electric field intensity at point P due to charge minus q. So E1 is equal to 1 upon 4 pi epsilon naught q upon r square. R is here a p square. A p square. Keep in mind, since we are taking about magnitude, so we will not put here a negative sign. So AP can be calculated as AP, right? AP can be written as AO plus OP. AP can be written as AP is equal to AO plus OP, or we can say OP is R plus AO is A. So AP is equal to R plus A whole. So putting this value 1 upon 4 pi epsilon naught q upon r plus a whole square, and direction is along. Direction is along what direction? E1. When we keep the plus q charge here, it will get attracted toward the minus q. So direction will be along this E1. This is the direction along PA. So we write along PA. Right? Similarly, now calculate E2 vector. E2 vector is equal to 1 upon 4 pi epsilon naught q upon BP square. BP square. Similarly, we can find 1 upon 4 pi epsilon naught q upon BP square can be written as OP minus OB. OP minus OB. So we will find BP. So OP is R and OB is A. So this becomes R minus A whole square, and direction will be, since this is positive charge, this is also positive charge, so it will repel. So direction of electric field will be outward. So we can write it as along BP produced. BP produced. We will write the direction is along. Here we will write along BP produced. Right? Now our third step was apply the superposition principle. For applying the superposition principle, we know that E1, E2, since both are acting in opposite direction, so net resultant will be subtracted. Now the question comes, which one will be subtracted? Either E1 is subtracted or E2 is subtracted. Now let's come to the which one is the bigger. Here R plus A is in the denominator and R minus A is in the denominator for E2. Since smaller value is in the denominator of E2, so E2 is greater than E1. So here we will write E2 is greater than E1. So net value of E can be written as E2 minus E1. So E2 is 1 upon 4 pi epsilon naught. Q will be taken common. We are left with 1 upon R minus A whole square minus 1 upon R plus A whole square. Now when we solve it, E comes out to be Q upon 4 pi epsilon naught R plus A will go this side and R minus A will go this side. R minus plus A whole square minus R minus A whole square divided by, it will become R square minus A square whole square. Taking LCM, R square minus A square whole square. So this will become E vector is equal to Q upon 4 pi epsilon naught. Opening this, R square plus A square plus 2AR minus, when we keep minus sign here, internal sign will be changed. So R square, here it will come plus, but due to this minus, plus minus minus A square minus 2RA minus minus plus. So this become plus 2RA upon R square minus A square whole square, right? So E vector will become R square A square cancel out, we will left with 4AR. Q upon 4 pi epsilon naught Q 2A into 2R upon R square minus A square whole square. So next step was put Q into 2A is equal to P. So E vector is equal to P vector into 2P into R upon 4 pi epsilon naught R square minus A square whole square. Next step was, for the short dipole 2A is very less than R, so ignoring A square. When we ignore A square, this will become 0, right? And this will become, A square will become 0, A square will become 0, so we'll get R4 will become R4, so R C R cancel, we'll get with E vector magnitude is equal to 2P vector upon 4 pi epsilon naught R cube along E2, right? That is along the axial line of dipole. Along axial line of dipole. Clearly E is inversely proportional to 1 upon R cube. This was the important topic. So steps what we have taken is, first keep the unit positive test charge, find out E1 and E2, then use the superposition principle, right? After that put Q into 2A is equal to 2P, Q into 2A is equal to P, and finally for the short dipole. That's all.